All right, so now we're looking at topic 6.11 in your syllabus, and this is all about recurrence relations. So we're going to start by defining a recurrence relation, and you've probably seen this when you started to study sequences and series. A recurrence relation is what we've called before a recursive sequence. So let's get over here. And what that means, a recursive sequence or a recurrence relation, is where we have consecutive terms, we use consecutive terms to define the sequence. And it doesn't have to be a sequence, which is why we call it a relation. And if we use consecutive terms rather than a more general n value, then we also have to have initial conditions stated. In this course, we're going to look at first degree and second degree recurrence relations, and that the degree tells us how many previous terms or how many consecutive terms we're looking at to define a sequence. So, for example, if we look at, let's say an arithmetic sequence. So an arithmetic sequence is one where we take a term, and to get the next term, we take the previous term and add the, what do we call that? Common difference. So this would be the recursive definition of an arithmetic sequence, and this would be a first degree recursive relation because we're using one previous term. The Fibonacci series, where we take the sum of the previous two terms, this is second degree. This is first degree. And in general, we say that a first degree linear recurrence relation has the form u sub n equals a times u sub n minus 1 plus some function of n. So in this case, our function was a constant. If this component is equal to zero, then we say it's first degree linear homogeneous. And that happens when f of n is equal to 0. All right, so second degree linear, similar, except now I'm going to have two terms, u sub n equals a times u sub n minus 1 plus b times u sub n minus 2 plus f of n. And again, if f of n is 0, we also get homogeneous. All right, so that's our definitions. Let's see that we hit everything. Yep. All right. So here's definitions, and I'll see you in future videos with examples.